we now move on to parts C and D, where we have two more linear programs to solve. Just like in the previous couple of examples, we start by sketching the feasible region. So in other words, we temporarily ignore the objective function and then just sketch the region resulting from the constraints. Okay? And again, just for the sake of time, I will kind of skip over the work and show you what the feasible region looks like. So in part C, our feasible region is going to look like this. We have a vertex at 3, 0. Let's see, 4, 5, 6. Another vertex out here at x equals 11. Another one at, let's see, another one right here at the point 2.2, comma 1.6. And then our feasible region ends up being actually a triangle connecting these points. Now again, I'm skipping over a lot of work here. Basically, you would have to sketch each of these two constraints. And then, let's see. You'd have to sketch these two constraints and then see what those look like. And then determine which side of the lines you wanted to use to figure out what your region looked like. Once again, if it's unclear how to do that, go back and review the example in section 5.2, and that should refresh your memory. Okay, but anyway, in this example, this is what our region looks like. It's this thin little triangle. Okay. And we have all three of our vertices here. 2.2, 1.6 is one, and then x equals 3 and x equals 11 are the other. So now that we know what the vertices are, the next step is to check those vertices. So I do that just by plugging each of these three vertices into the objective function. And again, this is what we're plugging into. So my vertices are 3, 0, 11, 0, and the strange one, 2.6, sorry, 2.2, 1.6. Okay, so plugging in 3, 0, I am going to get minus 12. Let's see, plugging in 11, 0, I have z equals minus 44. Excuse me. And plugging in 2.2, 1.6, I get minus 8.8 plus, let's see, 6 times 1.6, I believe is 9.6. And so that turns out to be positive 0.8. So it looks like that's actually our maximum, and our minimum is this minus 44. So we have a max of 0.8, which occurs at 2.2, 1.6, and then a min of minus 44 at the point 11, 0. Okay, let's look at part D. Proceeding as we did before, the first step would be to sketch the feasible region. And one thing that makes this problem a little bit different from the other three parts that we've seen in example 1 is that here we have three constraints. So our feasible region will look a little bit more complicated than in the previous examples. But what our feasible region looks like here is the following. Let's see. We'll have a vertex out here at 9, 7. Another vertex here at 4.2, 0.2, 2.8, and then another one at 2 1/4, 4.75. So that's 2.25, comma, 4.75. And we end up with this triangle. And, I'm doing things a little bit out of order here. Since I already know what the feasible region looks like, I'm just sketching the vertices to begin with. But if I were starting from scratch, I would have to draw the lines for each of the constraints, and then once I was done, I'd have to figure out where they intersected to actually figure out what my vertices were. Let's see. And so this is what my region looks like in this problem. So now it's a matter of plugging each of these points into my objective function. So I'm plugging into this. So I need to check my vertices. And let's see, this gives me, if I plug in 4 to 2.8, I'm going to end up with z equals 33.2. If I plug in 2 1/4, 4.75, I end up with z equals 31.25. And then if I plug in the point 97, I end up with z equals 74. So I have a maximum of 74, which occurs at the point 97, and a minimum of 31.25, which occurs at 2.25 and 4.75. Okay.